open or shut a door, or you push or pull the door by exerting a force, or when you sit on a sofa, you apply a force which changes the shape of the sofa. So when you push or pull an object, you exert a force on it, which may change the state of motion of the object or the shape of the object. So in this chapter, we will be studying about force and its effects and what is pressure. First, we'll be starting with force. So force is a push or a pull of or on an object due to its interaction with another object. So it is a push or a pull of an object due to its interaction with another object. So force basically have two components. The first is the magnitude, that is the number, and next is the path which it follows. So in general, more than one force may be acting on an object. However, a single force can also be acted which produces the same effect as produced by all the forces which are acting together, is known as resultant force or the net force. Resultant force. So if particularly we have an object, there will be two opposite forces acting on it, but the final outcome will either be in this or in this way. So this is known as the resultant force. So the final outcome which we get on an object due to the combination of various forces is called the resultant force or the net force. So resultant force can also be caused due to two ways. So first one is when both the forces are applied in the same way. That is, both the forces are in the same direction, or both the forces are in the opposite. So when both are in the same, then we have to sum up the forces to get the resultant force. If they are opposite, then we have to find the difference in between so that we get the final way. And in these both, whichever is stronger will be the path which the object follows. Now we'll study what is the cause of force. What is the cause of force? So the main cause of force is the interaction between an object with the other. So at least two objects must interact with each other for a force to come into play. So cause of force should at least involve the interaction between two objects. So when you push a door, the force is a result of your interaction of your hand with the door. So this is the involvement of at least two objects for the force to take place. Now, what are the effects of force? So let us start with the first effect. That is, it can move a stationary body. So suppose there is a car. So when you push a car, it starts moving because of your applied force. So a force can bring a stationary object into motion. So that is the first effect of force. It can bring a stationary object into motion. Next, what is the second effect? So it can change the speed of the body. So force can increase or decrease the speed of a moving body, or even can stop a moving body. So suppose you are driving a car. When the brakes are applied, it comes to rest. So by this we can understand that force can either increase or reduce the speed of a moving body. Next, the third effect is it will change the path of a moving body. So when a batsman will hit a ball with his bat, he exerts a force on the moving ball to change its direction. The fourth effect is it can change the shape or the size of a body. So when you apply a force on an inflated balloon by pressing it between your arms, then its shape will change. So suppose you have a balloon. So if you press the balloon in both the ways, then you can see that it slightly shrinks. So thus we can observe that its shape will change. Or when you're rolling a small ball of dough on a board, it changes its shape or its size. So we can conclude that a body cannot move by itself from rest, or change its speed by itself, or change its path by itself, or change its shape by itself. There should always be an application of force for all these effects to take place. So now we'll understand about different kinds of forces. There are two types of forces. First one is the contact force. So these are the forces which come into play only when the two interacting objects are in physical contact with each other. So when two objects which actually cause the force are in physical contact with each other, then we can say it is to be a contact force. Or in other words, when there is a physical contact between the two interacting objects, then the force exerted is known as the contact force. So the examples of contact force, the first one is the muscular force. So these forces exerted due to the action of muscles are known as muscular force. For example, when you lift a bucket of water, your body comes in contact with the bucket either directly or by the means of a rope. So this comes under the muscular force. Or the animals like bullocks or horses or donkeys carry out many difficult tasks by using the muscular force. They lift heavy loads. So all these come under the muscular force because they are action of muscles. Next is the frictional force. What is frictional force? It is a force which comes into play when one body will think of moving or actually moves on the surface of another body. So the path of the friction acting on an object is always opposite to the relative motion of the objects. So if you're walking in this particular path, then the action of friction will be in the opposite direction. So this is called as frictional force. Some of the examples are a moving toy car stops after some time due to the force of friction, or a moving car will come to rest after traveling some length only if its engine is switched off due to friction. So when you pull the table, object on it remains stationary due to the force of friction. So force is very important. Friction is very important because it helps us in walking and holding things. Next, we'll study about non-contact forces. Non-contact forces. What are non-contact forces? The forces that the two objects exert on each other even when there is no physical contact between them is known as non-contact forces. So it is exerted by two objects but they don't have any physical contact between each other. So some of the examples, the first one is the magnetic force. So it is the force exerted by a magnet on another magnet or some other magnetic materials like iron, nickel, cobalt and alloys. This is known as non-contact force. And when we see a magnet, it will basically have two poles, the north pole and the south pole. And like poles of the magnets often repel each other. South and south will repel, north and north will repel. But opposite poles will attract with each other. So there are two poles, so north and south, and like poles repel while unlike poles attract each other. Next force is the gravitational force. So it is the universe In this universe, every object, whether small or large, attracts every other object by the force known as gravitational force. So, in the universe, every object will have this gravitational force. It will attract every other object which is around it. So, suppose there is a book. It actually tends to attract the surrounding objects around it. The gravitational force acting between any two bodies is same for both the bodies. So if we have a book and your hand, both your hand and the book exert the same amount of force on both the bodies. But when a heavier body and a lighter body attract each other due to the gravitational force acting between them, the speed of the lighter body changes at a faster rate than the speed of the heavier body. That is why objects close to the surface of Earth fall towards its surface. So Earth also exerts the gravitational force on us. So because we are lighter in comparison to Earth, they tend to fall down when we are away from the surface. Gravitational force is a very long range force and it is the weakest force in nature. It is important to remember that gravitational force is the weakest force in the nature, but it has a very long range. Next force is the electrostatic force. So it is a force exerted by a charged body on another charged or non-charged body. So this force comes into play even when the bodies are not in contact. That is why they come under the non-contact forces. Here also the like charges repel each other while unlike charges attract each other. And the electrostatic force is stronger than the gravitational force. Electrostatic force is stronger than the gravitational force. So with this we understood the non-contact forces, that is magnetic force, gravitational force and the electrostatic force. And the contact forces we have seen muscular force and frictional force. With this we have completed the part which includes force. Next we'll be studying about pressure. Pressure is defined as the normal force per unit area. So pressure is normal force per unit area, which can also be written as thrust by area. So the force acting on an object is perpendicular to the surface is called the thrust. Pressure depends both on the amount of force which is applied and the area over which the force is applied. The SI unit of pressure is Pascal. And when equal amount of force is applied on two different areas, then the pressure will be more in case where the area is smaller. So a broad handle is provided in suitcases, which causes less pain in hand because the weight of the suitcase acts on a large area. So the pressure will become less. Now we'll understand the pressure exerted by fluids. So fluid is both liquids and gases are collectively called fluids. And liquids and gases exert pressure on the walls of the container in which they are placed. So if a balloon is basically placed or water is just dropped into the balloon, we can observe that the balloon bulges outwards, which shows that the liquid exerts pressure sideways also. Next, atmospheric pressure. What is atmospheric pressure? So the envelope of air surrounding the earth is known as atmosphere. So this is the earth and the envelope of air which is surrounding the earth is known as atmosphere. And the air has a weight and it extends up to many kilometers above the surface of the earth. So the pressure exerted by this air is called the atmospheric pressure. So how do we do the calculation of the atmospheric pressure? So consider an imaginary cylinder of air having a unit base area and extending up to infinity. So the weight of the air present in the cylinder is called the atmospheric pressure. So atmospheric pressure is the direct result of the total weight of the air above the point per unit area at which the pressure is measured.